Yeah, right now we want to look at how basically the introduction numpy. So basically you can actually type in Colab and then you will kind of point to this place. So with that, right, first of all we need to run this. So it's like the introduction to numpy. So you import numpy as np, and then the second part is from the Google Colab you import drive mount, and then the content is drive. Basically we import that. So at the moment actually I set up my lab, my Google Drive. You see that it's the same Gmail, right? And I have put the intro of numpy inside here. Probably this is right now, and then I can maybe run this from here. Right. So once it's run, you actually import the introduction to numpy that I was just sharing earlier into this particular slide. So there you run. It will take probably some time. Yeah. So while running, right? Yeah, it's kind of ran already, so it's kind of mounted. So I'll kind of walk through this at the same time. So numpy array as a size we fix when it's constructed. Elements of numpy are the same as data efficient, and these elements can be a floating point for 2D metrics. First argument there is a triple and rows of element. So data np array 2, 4, 6, 8, 10, 12. You can kind of run this. Then the expected, yeah, and then the data is 2, 4, 6, 8, 12, right? So you can actually run the array, and then you actually appear, yeah. So it actually becomes an array. Data, so you can run this data at name. So it will be 2. Shape, can actually run the shape, data.shape at 8. Then basically you come out with 3. Yeah. So you can just take it out again, and you run data at data.shape is 3, 2. Okay. So now you can have a data size. Data size is 6. Yeah. Okay. 2, 4, 1, 2, 3, 4, 5, 6. And then you can run the data D type. So this is integer 64. Okay. So np array 1, 2, 3, and then data type is np integer. So if it's integer, you run this. There's some traceback error. Attribute has no attribute of integer. 1, 2, 3. Let's try to run again. Okay, not sure why. Let's try to have a float array 1, 2, 3. Complex number. So attribute data. Okay, let's see here. Erase attribute form integer site. Data type np integer attribute data arrn. Okay, and clear the output first. Has no attribute integer. Okay. Don't know what happened. Try to run again. It's integer 1, 2, and 3. Most common has no attribute of integer. Okay. Data type equals to MP integer. Yeah, that's correct. Okay, the way, let's go on further. Type of MP array. I'll run this. Data type is MP float. Imaginary data. The array that can add in a complex data seems to be okay. Real data, image 0 0 0 vectors 5 3, right? And then you run empty, functions empty, lowercase 1 2 3 4 5 6 they run. Yeah, array 3 x plus y 1 plus 2 3 plus 4 5 plus 6. Yeah, so an array of x plus y 3 4 7, so you make it like transpose into string. Yeah, 3 7 8, so AT, A equals to your, so you slice right now x MP 1 2 3 4 5 6, y MP 2 4 5 6, right? And n is from the second column onwards, right? Sorry, yeah, 0 1 2, so basically from second one, and then so it becomes 1 2 3 4 5 6 for your x. So 0 to 2, yeah, 0 to 2, basically you run from your 0 to 1 2 3, right? 0 1 2 0 to 2 4 5 6. So this is how it actually runs. NumPy 30 11 13 11 12 13 3 4 6 goes to y, so your x array can be 13 12 11 12 13 and 3 4 6. Yeah, so and then x equals 2, so you can basically becomes 13 when this is 2, right? 0 1 2, so this is 13. So 0 vectors on 0, you can run the 0 and then becomes all 0 or 5 1 2 3 4 5, representing 5 row and 3 column, right? These all zeros, 5 rows, 1 2 3 4 5 rows, 3 columns. And then what you want is you run to 2, your x is 2, right? So it shows 11 12 13 and 3 4 6. Yeah, your x yeah. So array from 2 onwards, yeah, so array can be shaped and the integer type is 64. So x plus y, z equals to x plus y. Yeah, you can run this and then you type. It takes a bit of time. Yeah, 14 16 and 19. Yeah, the array, yeah, 11 plus 3 is 14, so x plus y. So now we add up the rows into, so MP array 7 8 9 11 12 13, MP array, and then x and y. So basically you want to x plus y, but it's comma 1, right? Comma 1 is 0 1, the second row. Row column, second column, my bad. So this is second column, and then y is 1, which is this, yeah. So x plus y. Yeah, second column, right? 8 plus 4 goes to 12. 12 plus 10 equals to 22. So we have second row. 0 is the first row, 1 is second row. So second row and everything. This is first row, second row, and everything for your x. So second row for your y. So while you run, it should give you 8, 10, 40. This is the second row, right? Yeah. I'm still running. Yeah. So this is just the first, right? 4, 3, 4, 5. So x is 3, 4, 5. X1. Run your x1. Yeah. So this is 11, 12, 13, right? X comma 1, which is your second row. And y, first 0 is first row, then 8, 10, 4, the second row, right? And then you have x plus y, the first row plus y of the first row. So 11 plus 8 equals 19. Yeah. So this is a numpy array 2, 4, and an array of 6, 8. So you plus 2, 6 is 8. This is indexing. So 1, 2, 1, 3, 5, 6, 7. So indexing Z1. So you can index it, then the array become 1, 3, 5, 7, 9. So instead of this, right, now you can have Z2 equals Z plus 1, integer where 0, 1, 2, 3, right? Then point out Z as an integer. Yeah. So 0, 1, 2, first, second, third column, first, second, third column. So when you have an independent array of 0, 2, 3, then you have an array of 1, 5, 7. Yeah. So this is a way to write indexing a numpy using a logical index 1, 3, 5, 7, 9, right? Is greater than 6. So 1 is not greater than 6, it's false, 3 false, 5 false, 7 is true, greater than 6, and 9 is true. Then you have Z1 greater than 5, you run. So bracket is to kind of form the matrix, right? So 7 and 9 greater than 5. Greater than 6 is also 7 and 9. Yeah, so integer Z1 is greater than 7, right? So it's false, 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 true, true. So this is 7, right? So now maybe let's try this is greater than 7. Then you run. So this becomes false. Yeah. So Z is integer. Because it's greater than 7, then it becomes only 9, right? So Z2 you can also run. So array of 10, yeah, because it's greater than 10. Yeah, so Z2, right? Yeah. So you can also run U1, 2, 4, 5, 6, then 0, 3, 3, 0 to 3, right? 0, 1, 2, 3, right? 0, 1, 2, 3. So it's excludes the n before 3. So yeah. So when W is equals to 3, you find out U1. So 1, 2, 3, 4. Okay, so it's like it's at the when the W is actually equals to the whole thing of 3. So this is numpy array. We can actually plot this. Let me clear this first. Yeah. So you plot matplot. Yeah. Pyplot as plot. N space 0, 100 and 10. Then the line space 0, 100 and 10, and you print x, then you plot xy. So 0, then 22, 23, 22, 33, 44, up to 100, right? Yeah, in a step of kind of 10, and then you plot x and y. Yeah, so this is one way to plot. Oh, not sure what happened. Some errors. Since a log space, you can plot a log. Let's try. Yeah, then you can actually plot log. Yeah, both sides. This is shape array, and then probably shape of 2 and 3. Visualization. This is still plot. You can actually plot 0, 14, 9, 15. Yeah. So 0, 14, 9, 15, then 19. 25, sorry. Yeah. So line space is 0 to 20. 0 to 20 line space. Yeah. So this is to plot to the power of 2. When you run this, it actually plots it. So let's try to the power of 3. Yeah. Then try to run and see what happens. Yeah, so it's to the power of 3. Some words argument, I can run 2 lines. BO is blue, G is green. Yeah, then when you run this, it gives you 2 different lines. Then with marker size 4 marker. So let's try this marker size maybe 8. Then we rerun, see what's the difference. You see it's much bigger, right? Yeah, blue the 0, and then G as a square. Yeah, let's try this as maybe 16. Oh, maybe 16. It should be bigger, right? So it's a way of visualization. Yeah, space. So this is plot. Right, you can plot 0, 1, 2, 0, 1, 4 in red square. Okay, red square. So you run this. Wow. So this is how it can be plotted. 0, 0, 1, 1, 2, 4, 2, 4. Yeah. Additional function. This is to add a little plot. Like my title plot is XX title, or we can just try to say this is for exponential curve title. Then you run. Exponential curve title. You import numpy and a matplot. So you have line space y1 equals to the power of 2, y2 to the power of 1.7. Then you label. Yeah. So you see you label x and y. This is label your x and label your y. Minimum minus 5, right? Then maximum is 11, up to 11. So minus 5 to 11, and this part y is minus 5 to 105. Let's change this to say 200, and we change the max to your side to say 21. Yeah, there you run. It's still quite small, 10, right? Then your string actually has opened up. Yeah. Okay, so yeah, so it's 10 to 20. So let's try to this line space. Yeah, and you actually can plot this way. So logarithm is the same. You can plot a log plot, power 2, power 3, but you log both sides. And then this is how you can run. And you semi-log. Yeah. Then this is plot in a different space. Generating histogram, you can generate a random number up to 1,000. And let's try up to maybe 5,000. Then you try to run. Just now the plot is to 1,000. Then when you join to 5,000, yeah, it's a bit more. Let's try to run a little bit more, so 100,000. So this is how it looks like. Gamma distribution. You can have a different plot density, and then this is how it can be plotted. Time function basically is a percentage of time, right? It's not found because this time percentage is not found. Occur distance, yeah, then you actually have 4 to 1,000. The user speed, you'll basically see the user speed. Yeah, so basically this is very introduction to NumPy. Yeah, thank you for everyone.